Hello, this is Matthew Feingold. Today I'll be demoing my final project for GAM 490 at DePaul University. For this project, I've taken a 2D physics-based shared screen local multiplayer game called Mega Race and modified it to allow online networked multiplayer for any two computers on the same local subnet. In order to show both of my computers running the game, I'm recording the video on my phone, so I apologize in advance for any potentially shaky video footage. So I'm going to start by firing up a copy of the game on my laptop, and so I'll just do that now. Here's the kind of the lobby screen, the load screen. And here's the output window in Visual Studio. And what you're seeing here in the output window is a basic log of the client-server connection process. When the game starts, it attempts to connect to another copy of the game that is running as a server, and if there are no computers on the local subnet running the game as a server, our copy of the game stops its attempts to connect to a server as a client and begins running as a server itself, which is, as we can see here, is what happened. It looked for discovery response messages from the server, didn't find any, and so now it's changing to the server mode. So when the game switches to server mode, I just put some simple debug print statements there, and that is what was there. So also, before I fire up the second copy of the game, I wanted to point out that I can attempt to move on here by pressing the spacebar, which is how you would normally move on to the game, but it won't allow you to do it until there is a connection. So now I'm going to start my game on my desktop. Here it is. And in the debug output window, you can see it searched for the server and it found one at, here's the IP and port. And so it connected to each other. And now, if I press space on either of the copies of the game, I can move on from there. So I'll press the space bar here, and we can see it moved on to both. So here for the game, I'll do some control this on my desktop here. You can see the desktop controls the blue ship, and the physics is being run. The physics simulator is being run on the server on the laptop. You can see here both games are synchronized. I can shoot missiles. I can lay mines, and you can see it comes out there. We have synchronized that. If I run over one of these, my ship will get destroyed, I'll lose a life. I can shoot the green ship. And likewise, I can go over here and control the green ship on my laptop. And destroy the blue ship. And when one ship loses all its lives, so if I get the blue ship one more time, a point will be added to the green side there. And if I do this a couple more times, first the 3 points will win, and it'll go to the game over screen, and then if either the client or the server presses spacebar, they'll both move on back to the kind of load screen lobby phase. And and then you can move on again by pressing space to sorry, this is a little tricky. You move on by pressing space again. So in order to get everything working, I'm sending packets back and forth between the client and the server. The physics engine is running only on the server on my laptop to guarantee synchronized position data for moving objects such as the ship, the missiles, mines, etc. And also that the collisions are the same on both servers, or both copies of the game. So when the ship collides with the wall, for example, I'll send a packet of data that contains the ID of the ship and the ID of the wall, and I'll send that both back to itself on the server and also to the client. So then when both copies process their packets, the outcome will be deterministically figured out, and the same will happen on both. So if I press space now, both copies will move on, and I can press space again, both copies are going. So we can play a couple rounds like this, and I'll continue to talk about the data I'm sending across as packets. So for the ship movement, that's all driven by the physics simulation, which is only occurring on the server side. So when I press forward, the physics body associated with the ship is it has force applied to it, same with the rotation, in order to simulate physics-based movement. So when I want to move a ship, I send a packet containing the command for the force to apply to the ship's body, and I send the ID. So the server can the server will send itself a message, and the client will send the server a message. The server can only control the green, the server can only control the green ship. So it will only send messages about the green ship, its movement and rotation, and the client can only control the blue ship, so it'll only send messages about the blue ship's movement and rotation. So when the server receives these messages about both ships, it will then apply the force to the physics bodies, and the physics simulation will update the position, and then the position will be sent as packets across the network to both the server and the client, and the the two copies will update the positions of their objects based on the data sent by the collision system. I have dynamic ID, like a dynamic ID system for the missiles and mines. So when one is created, the data that's sent across to trigger the creation also sends across a unique ID, which can be which is used to construct the missiles and the mines on both copies, so they have identical IDs for these objects, and then when they need to take action on those objects, I can use like a find function to find the same objects on both machines and have synchronized behavior in terms of what objects are being accessed. That's mostly what I wanted to talk about, just the lobbying system with connecting and the sending packets across, I have an input queue and an output queue for the packet sending. I have my own data structures to handle that, and then when I process the queues for the output queue, I'll serialize everything and send it across the network, and also do local loop back into the local input queue. And then when I process the input queue, I will read messages from the network and then deserialize them and push them as messages into the input queue, and then read all the messages in the input queue and process them based on their message type and trigger the expected behavior based on those message types. And yeah, I think that covers about everything. So yeah, thanks.